morning, everybody. Welcome to our robotics class. This is week 21. So we are continuing in unit 4. So if you remember last week, we learned about the bumper sensor, right? And it was a pretty basic code. You were just able to test out using your bumper sensor. So when the robot touched the wall, right, and the bumper sensor was pressed, the robot stopped, right? And so we just did some basic code. So we're going to move along and we're in lesson 2 now. So we're going to be learning how to use the wait until block. So we're going to be creating a project with the bumper sensor and the wait until block. And there's actually a mini challenge that we will be completing. So that'll be the code that you guys will be doing this week. Okay. So I hope at this point, everybody knows how to go into here and rename your project. So the best thing, always put your name. So I would put my name and then I would put the name of the lesson. So this is unit 4, lesson number 2. And this is going to be the mini challenge. And then I would just click rename. So this would be a great, just kind of clean slate. I have it named. I put my name. So that way, when you send me the file, I know it's you, right? And when you send me the file, I know which lesson it's for, because especially some of you guys, well, it's not some of you guys, like most of you guys send stuff in late. And then if I'm on week 21 and you're sending me something from week 19, I don't know what it is if you don't label it, right? So you need to label which lesson and what it's for, okay? All right, so we're going to be learning about the wait until block. So this is a control block. And it's able to help us to let the robot know what to do, right? So a project will not move to the next block in the stack until the condition in the wait until block reports as whatever it is, true or false, right? And so we will be using that block during the project. So for your information, non-waiting and waiting blocks determine when the next block begins a behavior, right? So for example, if it says wait until whatever, then it won't go to the next block until that happens, right? And then a non-waiting block, it's just a block where it just happens, right? You just connect them together and it just follows the sequence. So waiting blocks like the drive for or the turn for, they complete their behaviors before moving on to the next block. And non-waiting blocks, such as the drive block and the turn block, they continue to move through the stack of blocks, even if the behavior in the non-waiting block is not complete, right? So certain blocks like drive for and turn for, they can be waiting or non-waiting blocks. And you could select the arrow on the block to turn it from a waiting into a non-waiting block. So like drive forward for 200 millimeters, that's going to just do exactly what it's supposed to do, right? Drive forward for 200 millimeters and don't wait. It's going to move on and it's going to do something else, right? So a non-waiting block would be a drive forward block because it's just going to drive forward. And then a wait until block is going to allow you to put something inside of it. So if you remember the little blocks where you can move something and drag it into it, so you see kind of this empty spot here, you can actually drag something in there. And if you look here, what they did is they said, when started, drive forward, wait until left bumper is pressed. So you're going to keep on driving until the left bumper is pressed, right? And then it says drag a stop driving block and add it to the project. Stop driving, right? And then what will happen, it'll keep going forward until the left bumper button is pressed, and then it'll stop driving, right? So they kind of give you a little breakthrough to understand this. When started, remember, you can always just read code as you would read something, right? Go block by block and read what it's going to do. When started, it's going to drive forward. It's going to wait until the left bumper is pressed, right? And so if it's not pressed, it'll be false. If it is pressed, it'll be true. And then it's going to stop driving, right? So that's pretty much what it would do. So to follow a visualization of waiting versus non-waiting blocks, watch the code execution highlighting function in the VEX Code VR. So you know where it like kind of highlights the blocks as it's going along when you're running the code. The green highlight will appear around the wait until block until the condition is met, right? This is because the wait until block is a waiting block. And the green highlight will appear to skip the non-waiting blocks because these commands are quickly executed. So you see how it's kind of like a green highlight? That means it's doing that part of the code. And it won't stop doing it until whatever the condition inside of the block is met. In this case, the left bumper being pressed. So that sensor is being pressed and it's showing up as true, and then it will move on to the next part of the code. So you will have to kind of test it out, which is what we're going to be doing in a few minutes. So we're going to be using the wall maze playground again. So you guys probably remember this from last time. So let me pull it up. I'm going to be using the wall maze. So here's our wall maze. And we will be doing a mini challenge in the wall maze. So this is our wall maze. This is what it looks like. Okay. You might remember, hopefully remember it from last week. And we're going to drive through the wall maze playground, the VR robot will need to turn and keep driving. And when there is a collision with a wall, right? So it's going to keep driving and turning and driving. When it hits a wall, then it has to figure out what to do, right? So we're going to be removing the stop driving block and replacing it with a turn for block, right? And then we're going to tell it to turn right or left. So if you look here, it says when started, drive forward, wait until your left bumper is pressed. When it is, then turn left for 90 degrees, right? And then what will happen? It will follow through those steps, right? And then you could even use multiple wait for blocks in the same project. And then it could help it to keep going through the maze, right? So you see they added another drive forward, wait until the left bumper is pressed, and then turn right for 90 degrees. So we're going to be trying to do this. And so we're going to try to run the code. So then for the mini challenge, it says that you're going to create a project where the VR robot drives from start to the letter A. And we're going to be using multiple wait for blocks and the bumper sensor. So we want to drive forward, turn left, drive forward, turn left, and we want to go to the letter A. So I'll show you what it looks like. Let me put on the video. Let me see if I could show you guys the video. So this is what it's supposed to do. Drive forward, turn left, drive forward, turn left, and then drive forward to the letter A. So that's kind of what your mini challenge is that you guys are going to be doing. So what I want you to do right now is go into VEX Code, do a new project, make sure you rename it, put your name, Unit 4, Lesson 2 mini challenge, and then we're going to pull up the code for how to do this. Okay, so I put up the code to show you guys just to kind of speed it up. But we're driving forward. We're waiting until the left bumper is pressed. And then when it is, we're turning left for 90 degrees. Then what are we doing? We're driving forward. And again, we're waiting until the left bumper is pressed. We're turning left for 90 degrees. We're driving forward. And then again, it starts all over again. And then we stop driving. So let's test this out. I'm going to open up the playground in the wall maze and let's see what happens with this. I always have a hard time getting you guys to see it on the screen because you know why? Because the robot's all the way down here. I hope you guys could see it. You might have to when you do it on your computer. So here we go. So the robot's down here at the bottom. Okay, it's turning left, going forward, turning left, going forward, and then it's hitting the A. Oops. And so that's exactly what we wanted to do. So what you're going to do is, I'll try to make the code a little bit smaller so you could see it in one shot, but you're going to be using this code to get your robot to move to the letter A in the maze. Okay, so I pretty much, this is the answer. So I always give you the answer with the code, but you're welcome to just go and try it on your own and then just come and recheck it with the video to make sure that you got it correct. Okay, so pretty basic. You can send this to me. We're really just kind of starting out with the maze, getting comfortable using the bumper sensor and using the wait for block. And then that's allowing us to be able to go through the maze, right? And that's what we're doing. Okay, so then let me show you the quiz that goes along with this. So which statement is true for non-weighting blocks? So let's go through this. They allow the stack to continue even if the block's behavior is not yet complete. That sounds pretty good, right? They pause the rest of the stack until that block's behavior has been completed. They don't. They cause the VR robot to shut down. No. And they are always blocks from the looks category. No. So we know it's A, right? They just continue because they're non-weighting. What do weighting blocks do in a VEX Code VR project? They repeat a behavior forever. They don't. They pause the stack until that block's behavior has been completed. Yes, that's the answer, guys. So we're just getting you to see the difference. So with the non-weighting blocks, it just keeps going through the blocks. You have one block, it does it. Next block, it does it. Next block, it does it. With the weighting blocks, it will wait on that block until it meets whatever the condition is, and then it will move on to the next block. So hopefully it's starting to make sense to you in the coding world that there are these different types of blocks, and when you use them, they do different things, right? How does the highlighting function help to visualize weighting versus non-weighting blocks? So what do you guys think? The highlighting function. So pretty much, here, hang on, sorry, I lost where I was reading. It explains how to use weighting and non-weighting blocks. Do you think it does that? It stops the project when a weighting block is being executed. It moves blocks to show how the project is being executed, or it highlights each block as it's being executed. That sounds about right, doesn't it? And that is what it does. It highlights each block while it's being, and it helps you to see, oh, it's doing that now. Oh, it's doing that now. Oh, it's doing that now. And this helps when you have an error or a bug, because you can go back and as it's highlighted and you're watching it and you're like, oh, it's stuck over there, and you see where it's highlighted, you could see where your mistake is in which block because it's highlighted. And it's so helpful because then you go back to that block and you're like, oh, I just need to change this, and then it works. So hopefully you realize that it even does that. I hope you guys are looking at the code when you're doing it. Guys, this is such a great learning experience every week because it builds upon the different blocks of code, and you're learning about so much code here, different coding and things. So I hope you guys are really putting, like the effort into this, because I mean, otherwise you're kind of like losing out on the full learning experience. The wait until block is a control block that accepts Boolean values. So if you remember, like a true false would be a Boolean. So what do you guys think? What is it? So yes, it does. It's true. It does accept Boolean. Which of the following describes the wait until block? It will move to the next block while checking a Boolean condition. It will execute the next block after waiting 1 second. It will not move to the next block until the condition of the Boolean reports true. What do you think? That's it, right? That's just like the wait for. When the left bumper sensor is pressed or it's true, then it moves on to the next block. What will happen when the distance from block reports that it's less than 50 millimeters from an object? So let's read the code. When started, drive forward, wait until the distance in millimeters is less than 50, and then turn right for 90 degrees. So what will happen? The VR robot will turn right for 90 degrees. It's A, because if you read through the code, you see that the next thing that will happen is it will turn right 90 degrees. What will the pressing bumper block inside the wait until block report in this example? So let's say, when started, drive forward, wait until the left bumper is pressed, turn right for 90 degrees, and then drive forward for 100 millimeters. So when the bumper is pressed, what will happen? So let's think about this. Yes, the bumper released or no bumper pressed, it would drive forward when the bumper is pressed or drive in reverse when the bumper is released. It will turn right when the bumper is pressed or turn left when the bumper is released. So what do you think? When it's pressed, it's going to turn right, right? Because we know that, but it says when it's true, the bumper is pressed, or false when it's released. So we have to just think about what this block does. So what it does is it tells us, it reports back a true or false. And the true or false is true, the bumper is pressed, and false, the bumper is released, meaning it's not pressed. And so that's ultimately what it does. So that would be the answer. True, the bumper is pressed, or false, the bumper is released. Which of these blocks cannot be used as either a waiting or not waiting block? So let's think about it. The stop driving block, the drive for block, the turn to heading block, or the turn for block? Which one cannot be used as a waiting or non-waiting? So think about it. A stop driving, it's stopping driving. So there's nothing else happening. It's over, right? So I would say that would be the answer. What do you guys think? Which of the following best describes how to create a project where the VR robot drives forward until the bumper sensor is pressed? So let's think about it. Select the drive for block, then place the turn for and pressing bumper blocks underneath. Is that going to make it drive forward until the bumper's pressed? I don't know. Select the drive block, then place the wait until block underneath. Place the pressing bumper Boolean reporter block inside the hexagon in the wait until block. And then the next one says place the repeat until block with the pressing bumper Boolean after the drive block. And then the next one says place the drive for block under the when started block and add the pressing bumper and the set drive heading block. So this could be really confusing if you don't take it one step at a time. So we wanted to just drive forward until the bumper sensor is pressed. That's pretty much all we wanted to do. So we just want it to drive forward. So we know we're going to want a drive block as our first block. And then we want to put the wait until block, right? Until the Boolean block inside the hexagon is pressed, right? And so that's really the one that we want. We're just pretty using a drive forward, and then we have a wait until left bumper's pressed, and then that's it, right? That's kind of like our main thing that we've been using. So that would be your answer, would be B. So this quiz, definitely I would follow along with the video and like take notes and stuff, because it can get challenging, like understanding the code. But again, it really is just kind of like reading something. You start from the top and you read each block and try to figure out what it's doing and put it all together. And then you visualize it here. Oh, okay, it's driving forward. Oh, okay, it's turning left. Oh, okay. And it kind of helps you to figure it out, right? And be able to use the correct blocks. So hopefully you guys are getting the hang of this. So your homework is to do this code for the mini challenge and to take the quiz, right? So I feel like we've kind of established some sort of a, kind of routine with our robotics right now. So you should kind of know what to expect every week. But it does build upon each week. It does get a little bit harder. So you really do have to focus and make sure that you're, if you really want to understand the code, you have to take time to understand it, right? Okay, guys, thanks so much. I hope you have a good rest of your day. Reach out if you have any questions. Otherwise, I'll see you guys next time. Bye, guys.